Welcome to the ninth lecture of comprehensive data science, machine learning and AI course. Now, if you remember, at the beginning of the lecture, we had made one virtual environment named basic_ds pi underscore pi, basic_ds underscore pi 311. So let us first, we also made one directory of same name. So let us do a CD to that directory. I am showing this step many times because, so now we are in that directory. Inside that directory, there was another same named directory, but that was the virtual environment directory. So I again make CD and basic_ds underscore pi 311. But now this directory is the virtual environment directory or folder. Okay. Now inside this there is a scripts folder. So I again make CD, and then inside that script there is one activate script or activate what you say is shell script, and when you execute it, you can see that at the beginning of your command prompt, now it is shown that now we have activated that basic_ds underscore pi 311 environment, and then we do Jupyter underscore lab and Jupyter space lab, and I press enter. As soon as I press enter, the Jupyter lab will open. So I am doing this step in this sometimes in between I will do that step so that you don't forget this good habit of creating virtual environment and doing all the related tasks in one virtual environment. If you are doing some other project, then create a new virtual environment for that. This is my project. I am developing a data science course. So I have created a virtual environment that has named basic_ds. DS stands for data science. Okay. Now as soon as this Jupyter lab is written, immediately you will see that some this kind of, just wait for a minute. Some this kind, as soon as you type Jupyter space lab and then press enter, then some this kind of long messages will be printed, and finally Jupyter lab will open in a browser. I have already explained this whole thing in much detail, so you must refer to the earlier lectures also if you still don't follow. Here I am doing it just for the sake of a kind of revision. Okay. And once Jupyter lab opens in the browser, this is the topic which we were discussing: types of operators in Python. Arithmetic operators, relational operators, assignment operators, logical operators, bitwise operators, membership operators, identity operators. Okay. So from this we had discussed all except bitwise operators, because bitwise requires slightly lengthy discussion, and that lecture was already 30 minutes long, and I am planning to keep all lectures around 20 minutes. But anyway, these bitwise operators now. So bitwise operators perform operations on binary representation of integers at bit level. So this is first important thing. Its name itself suggests that these are not ordinary operators, and therefore mostly as a data scientist, it is very rare case that you will be required to use this. But whenever we are required to use it, supposing some rare condition, then at least you should be able to refer to this lecture. That's why this lecture has been included. Okay. So then these are the binary representations of integer. What is the meaning of that I am saying here? Say a is equal to 6 is one integer, but in binary it is represented by 110. How I am telling that also, that I will show only once because that is very elementary. Similarly, 3 is an integer, but in binary it is shown as 011. Let us see how. 6 and 3. Okay. So this is my 6. I will first write it as 4 plus 2. That means I am writing it as a sum of powers of 2. And then 4 I am writing as 1 multiplied by 2 square plus 1 multiplied by 2 raised to 1 plus 0 multiplied by 2 raised to 0. So you can see a nice harmony here, that 2 square, then 2 raised to 1, then 2 raised to 0, 1 by 1, different 1 by 1, different this kind of powers of 2 are there. So binary number is made by just this one whatever is the multiple over here. Okay. So when multiple is here 1, then here multiple is 1 and here multiple is 0. So when 6 number integer is to be represented as binary, then it is represented as 110. Similarly, if you want to represent 3, then first write 3 as 0 plus 2 plus 1. So try to write it as powers of 2, but if nothing is possible, then 1 is allowed. Okay. So then 2 plus 1. Now then I can write it as 1 multiplied by 2 raised to 0. Any number raised to 0 is 1. So that means this is 1 plus 1 multiplied by 2 raised to 1. So that is this 2. And then 0 multiplied by 2 square. Okay. So then that is this 0. Okay. So here this only you have to focus on this multiples. When you want to find binary representation, then you have to forget about the powers of 2. You have to focus on only multiples. So 0, 1, 1. So that means number 3 would be represented as 0, 1, 1, and number 6 would be represented as 1, 1, and 0. I think that this is very clear and very elementary. So this is the first and the last time I am showing this. Okay. Now this is how the bitwise operator binary conversion is done. Now let us see what each bitwise operator does. It acts on each bit like this. These are all called one bit, 1, 1, 0, and 0, 1, 1, like this. And they are used in areas like cryptography or network programming or embedded systems. I will discuss about this at the end. So then bitwise AND operator. It is shown by symbol ampersand, and it is a binary operator. So that means it will have two operands, A and B, for example. So here, for example, A equals 6, B equals 3. And if I write A and B, remember it is not 6 and 3, but rather 1, 1, 0 and 0, 1, 1. So because bitwise operator acts on binary numbers only. So what will be the result? Then this says that bitwise operators are very simple. They just add corresponding bits, and 1 will be added with this 0. 1 will be added with this 1, and 0 will be added with this 1. Okay. So then in that case, obviously, what will happen? So if both bits are 1, then the resulting bit is 1. Otherwise, it is 0. So if both bits are 1, then 1 and 0. So then the resulting bit is 0. 1 and 1, then the resulting bit is 1. And this 1 and 0, then the resulting bit is 0. Okay. So that means only this one bit, middle bit, that will be 1. So what will be the answer? Answer will be 0, 1, 0. Okay. 0, 1, 0 after doing bitwise AND between these two binary numbers, that is 6 and 3 actually. So now 0, 1, 0 is what? Then you can always write it 0 multiplied by 2 square, but that is 0. 1 multiplied by 2 to the power 1, so that is 2. And 0 multiplied by 2 to the power 0. So that is also 0. So ultimately only 1 multiplied by 2 to the power 1 is remaining. So number is 2 in decimal. Let us see if we get that number or not. We are getting that number. Okay. Now bitwise OR. Bitwise OR operator again compares each bit of two numbers between which the OR operator is put. But it is slightly what you can say more permissive than AND. Okay. So it says that if any one bit is 1, then the resulting bit will be 1. But if both bits are 0, then the resulting bit is 0. So again I take that same A6, and this is its binary, B3, and this is its binary. Now here explanation is also given. So 1, 1, 0 or 0, 1, 1. So if any one number is 1, that is enough. So first number, at least A has 1. So answer will be 1 for the first bit. Then here both are 1, so there is absolutely no problem. Answer is 1. Then here 1 is 1. So that means that that is also okay for OR operator. At least one bit should be 1 out of 2, which are being ORed with each other. So that means the answer of this is 1, 1, 1. Now 1, 1, 1 is actually what? 1 multiplied by 2 square. So that is 4 plus 1 multiplied by 2 to the power 1. So 4 plus 2, that is 6. And 1 multiplied by 2 to the power 0. So that is 1. So in that case, 4 plus 2, 6 plus 1, 7. So answer should be 7. When you OR these two numbers, then the answer should be 7. And you can see that we are getting 7. Here we are getting 2. Here we are getting 7. Now bitwise XOR. It also compares each bit of two numbers. But if the bits are different, then the resulting bit will be 1. And so it kind of gives incentive for being different, XOR operator. Okay. So that means, and if the bits are same, then the resulting bit is 0. So it kind of gives punishment for being same. Okay. So if same two numbers, 6 and 3. Now if I see here, then 1 and 0. So they are different. Incentive 1 result. Same 1 and 1 punishment 0. 0 and 1 incentive, so 1. So 101 is obtained, which is actually 5 in the decimal system. Okay. And here you can check that, and the number is 5. So XOR is shown by this symbol, then OR is shown by this symbol, and AND is shown by ampersand. Okay. That is first three operators. Now I think we have done that. Okay. Then bitwise NOT. NOT is called a unary operator. Unary because it is applied to only one binary number. So that means that there is no need of two numbers, maybe like 6 and 3. Just one is enough. So we will take any one number, say A equals 5. In binary, it will be converted into this. Now when you apply NOT operator, it just inverts all bits. So that means that 1 becomes 0 and 0 becomes 1. So all these zeros, they will become 1. Then this 0, it will also become 1. This 0, that will also become 1. While this 1 and this 1, these two, they will become 0. So if I write this, then what will be the result? Then the result will be 1, 1, 1, 1, then 0, sorry, 1, then 0, then 1, and another 0. Okay. Here I have written, after applying NOT operator to this binary number, you will get this binary number. Now, what is this binary number? If you convert it into decimal, so at that time it will be -6. Okay, it is for a system with signed integer. Now, I will leave this to you and try to find how this number is -6, this binary number, how it is equal to -6 in the decimal. But let us try to check if I am getting -6 or not. Okay, so I am getting -6. Now, bitwise left shift. So left shift operator shifts the bit of the number to the left by specified number of positions. So actually it is also a unary operator that you can see, because we are taking only one integer number whose binary representation is this, and then we are using this left shift operator, which is like less than symbol, and this not operator, that is the symbol, this is called tilde. Okay, this symbol you will find in key just above the tab key on your keyboard, and that also you will have to play. It is actually that backtick key. So backtick key, therefore tab key, if you this tab key plus shift if you press, then you will get this symbol which is called tilde. Okay, now these symbols are 2 times less than, that is called left shift. Now left shift, how many? Then let us take a simple example, just one, but you can take any number here, 2, 3, and it becomes complex. So I am taking 1. So that means what happens, this zero will, this actually all these will be left shifted. Now if all these will be left shifted, then the question is what will happen to this poor fellow on the left side, leftmost side. So it will it be pushed and just fall in the some kind of valley? Then no, it will make a round and it will attach itself here. Okay, so this is what is explained in this manner, that this is the binary representation of number 5, and when you do left shift by 1 digit, then this number, this 0 is moved here. So you can see this 0 will move here, this first 3 0 will remain, this 0 will be attached with it, so 4 zeros. Okay, fine, and this 101 will remain, and that leftmost 0 is now attached to the right side. So that means that leftmost 0 has been pushed. So that is what is happening. Now if you find the conversion of this, then you will get that this number is 10 in the decimal. Again, that is your exercise homework. I have already explained how to convert binary to decimal, but let us check. It is 10. Okay, bitwise right shift, that is just opposite of left shift, that you have to move the push the numbers from left side towards the right side. Here you in left shift you are pushing the number from right side towards left side. So here you are doing right shift. Okay, and it shifts the bits of the number to the right by specified number of positions. Here also I have given 1 just for simplicity, but it can push by 2 also or 3 also. So my number in decimal is 5 and its binary representation is this. Now I am shifting right by 1. Right shift is shown by this greater than symbol. So if you show it by this greater than symbol, then in that case you will, this 1, will it fall off the edge? No, we know now that it will be attached here. So 1000, that will be the 4 digits on the left, and this 0 will be attached here, and 010 which will remain, that will be attached to this. That 1 has been attached towards the left side. It has been pushed to the right, and therefore it has been attached towards the left side. So this is the binary representation of our original number 5, and after shifting, as I said, that here it will become 010 and 0010. So that is this 0010, and that one which is already on the rightmost side, that will be attached to the left side. Okay, so that is the it is not getting attached to the left side, but actually it is simply dropped. Okay, so that is the difference between left shift and right shift. Okay, so I am also doing this maybe after several years, so I forgot it. I'm sorry for that. But actually, as a data scientist, we will not require it, this bitwise operator almost ever. But still, it is good to learn them, because this low-level programming, assembly level programming, that is require bitwise operator embedded system. Now this is something where data scientists may encounter bitwise operator. IoT, you have learned that that is Internet of Things, in which smart devices are being made, and sensors are attached to various devices. Those sensors continuously keep on emitting data. That data is converted into its binary form, and if you want to control that embedded device, then you again have to maybe send a signal. At that time, you might need to manipulate the bits which you are receiving from that embedded system. Okay, but that is a highly specialized field, and an entrant into the data science is very rare to encounter this. Similarly, this cryptography also makes some use of data science. So at that time you may require it. Otherwise, it is not much. In cryptography is you know that whenever you write this in any web address, you write HTTPS. So that S is for secured socket layer SSL for that, and that whatever address you type or anything, that will be converted into cryptographic hash, and that you know that SHA 128 is one standard and SHA 256 is another standard. 256 cryptography is considered very strong and very difficult to break. Once something is converted into that cryptographic symbol, then it is difficult to break. Now these you will require as a data scientist, but you will require more as a data engineer perhaps. When you suppose want to deploy your machine learning model to a cloud, so at that moment you will require to SSH to the your cloud provider, so AWS or Azure or GCP. So for doing that SSH on Linux or Mac, you just can directly use your command line. But on a Windows machine, you have to use an app called Putty, and that Putty allows you to do SSH. And at that time, your key, there is a secret key. Only you should be able to access your cloud server. No one else should be able to access your cloud server. So that secret key is stored inside your computer by using cryptographic algorithm. So there this bitwise manipulation is required. Okay. So in next lecture we will be talking about this operator precedence. Thank you.